Section 7.3, hypothesis testing for the mean. These are our smaller samples. We're going to find critical values in a t-distribution. Instead of the z, it's a t-distribution. We're going to use a t-test to test a mean, mu, and then we're going to use our calculators to find the p-values and also t-values if we want to test the mean. So we need to identify the level of significance. That will always be given. With a t-test, you need degrees of freedom. Remember, degrees of freedom are n minus 1. Don't forget n minus 1, degrees of freedom. We're going to find the critical values, and none of us, I think, are using the table, so we can use inverse t in our calculator. And remember, it's area to the left with our degrees of freedom, which is n minus 1. Okay? And there'll be one-tailed, two-tailed tests, right tail, left tail, and two-tailed tests. And this is for the table, but none of us are using the table. So find the critical value, t sub 0, for a left-tailed test, given that alpha is 0.05 and n is equal to 0.2, or is equal to 21. Degrees of freedom then, 20. And let's do it in our calculators. In our calculators, you would do inverse t, area to the left is 0.05, and I believe it asks for degrees of freedom. Let's pull up our calculator and see if that's what it asks for. So there's my calculator. Inverse t, so second, distributions, inverse t, area 0.05, degrees of freedom 20. Negative 1.72. So negative 1.72. That is my t-value. It's my critical value. My t sub 0. Find the critical values, negative t sub 0 and positive t sub 0 for a two-tailed test given alpha is 0.1. If alpha is 0.1, then that would mean that this is half of alpha, or 0.05, and this is 0.05. So degrees of freedom, n's 26, so degrees of freedom would be 25. And so now, in your calculator, inverse t, area to the left, degrees of freedom. So let's do that in our calculator. Inverse t, so second distribution, inverse t, area to the left, 0.05, which is already there from the last problem. Degrees of freedom, 25. And it gives me negative 1.71 rounded. So if that's negative 1.71, remember that that curve is symmetrical. So this is positive 1.71. And if you want to find the positive in your calculator, you don't need to, but you could do inverse t, area to the left. So area to the left would be 0.95. And that would give you the positive one. So this will give you the positive answer, this will give you the negative answer. But you can just do it once and know that it's symmetrical. T-test for mean. T-test can be used when the population is normal or nearly normal. Sigma is unknown and your sample size is less than 30, just like the last chapter. Your test statistic t equals your sample mean minus the mean over the standard deviation divided by the square root of n. And the degrees of freedom are n minus 1. Just like last chapter, H naught H sub A, you need to state those. State which one's your claim. Identify alpha and your degrees of freedom. I would probably use your calculator and you could do the inverse t to find out where that rejection region is. You either reject or fail to reject, and then you interpret it. There is or is not enough evidence to either support or reject the claim. So used car dealer says that the mean price of the Honda is at least $20,500, at least. So the mean is at least that much, at least. At least means could equal that or it could be greater than that. You suspect that the claim is incorrect, that this claim is incorrect. You find that a random sample of 14 similar vehicles, so that's my N, has a mean price of, there's my X bar, and a standard deviation, there's my S. Is there enough evidence to reject the dealer's claim? Assume the population is normally distributed. I know what my H naught is. So they're talking about the dealer's claim. So that's why that's your C. Alpha was given. Degrees of freedom would be N minus 1. So I have alpha is 0.05. So if I take inverse T, sorry, of my area to the left, it's left-tailed because that's pointing to the left. Degrees of freedom of 13. I will get my T sub 0. So let's see what we get. Second distribution, inverse T, 0.05, 13. Negative 1.77. Yep, negative 1.77. There's my T statistic. So if I'm in the tail, remember, reject. If I'm in the body, fail to reject. So test statistic. X bar, when you read the data for your sample, the mean was 19,850 minus my mu here over the standard deviation divided by the square root of n, 14. So if we put that in our calculator, move my calculator over. So in my calculator, I like alpha y equals enter. So there's my fraction, and I have 19,850 minus 20,500, and my denominator, I'm going to do another fraction here, 1,084 in the numerator of the denominator, and square root 14. I need approximately negative 2.24. Negative 2.24. So negative 2.24 might put me right there. Since I'm in the tail, the alpha tail, it's a reject. And so I'm rejecting. So this is, so there is enough evidence to reject the claim. Is enough to reject. Use the word reject if the claim is H sub 0. Use the word support if the claim is your H sub A. An industrial company claims that the mean pH level of water in a nearby river is 6.8. So they are claiming this. You randomly select, what you're claiming, 19 water samples, and the sample mean, and the sample standard deviation. Is there enough evidence to reject the claim alpha is equal to 0.05? Okay, so now looking at this, equality, claim, equality, H sub 0. Okay, so the equality was my H sub 0. So equal to is the H sub 0, not equal to is the H sub A. Alpha and degrees of freedom. Alpha was 0.05, so both of these together are 5%, so each one is 2.5%. So inverse T, 0.025, degrees of freedom of 18. Negative 2.1. Negative 2.1. So this is 2.1. Let me take it out a few more spaces. 1, 0. It's 1, 0. Okay? So that's what these numbers are underneath here. So my test statistic, my x bar was 6.7. Mu minus 6.8 divided by 0.24 divided by the square root of n, which is 19. So let me put that in my calculator. And if you want, I already have a fraction here, so I might just edit these numbers. Let's see what happens if I edit the numbers. 19's in the denominator here. Up here I have 0.24. So I have 0.24. And then I have 6.7. 6.7 minus 6.8. 6.7 minus 6.8 divided by 0.24 divided by square root of 19. And I get negative 1.82 about. So negative 1.82 might fall right there. So that is a fail to reject. I'm in the body, not the alpha tails. Since this is a claim, here, just a minute, I'm failing to reject. Since that's a claim, we use the word reject. So is there enough or is there not enough? There is not enough evidence to reject the claim. So not enough evidence to reject the claim. Department of Motor Vehicles office claims the mean wait time is less than 14 minutes. Mean less than 14 minutes. A random sample of 10 people has a mean wait time of 13 minutes with a standard deviation of 3.5 minutes and an alpha of 0.1. Test the office's claim. Assume the population is normally distributed. So this is the claim we're testing. And this is my H sub A, because it does not have an equality. So that's my H sub naught. So let's go to the next page and do that. H sub naught. So there they are right there. So now let me show you another way to do this very quickly in your calculators. Here's my calculator. You would go to Stat, Test. This is a t-test. Last section was a z-test. So there's a t-test. I don't have data plugged in, raw data. I have the statistics. So my mu sub 0 is 14. So that's my 14. My x bar, when you read it, they said the mean for the sample is 13. My S sub x was 3.5. My n, if you read it, was 10. Up a little bit, 10. Okay, and H of A, look at H of A. That's what we want there, whatever H sub A is. So there's that. We hit calculate. And there we have our t-value. We also have the p-value, okay? And so on this, I don't care if you use t-value or p-value, but here's what I have there. This right here, if I'm looking at my p-values, remember if the p-value is greater than alpha, you would fail to reject, okay? You would fail to reject. since this is the claim, you use the word support. And there is not enough evidence to support my claim, because I'm failing to reject, you're leaning towards that one. So that's using technology. You could also check your t values. You could do an inverse norm, or inverse t, not inverse norm. Inverse t of your alpha, the 0.1 with your degrees of freedom, and figure out what the value is, and then compare it and see if you're in the tail, that alpha tail. If that's in the alpha tail, you would reject. If it's in the body, you'd fail to reject. And it'll be in the body. And that is, I think, all of them. That's all of them.